Welcome, everyone, to this evening's edition of Rush Virtual. This is Sir Master K, almost said the other way, um,
It doesn't matter.
also known as Wayne Brown, who's going to talk to us this evening about acid etching. Take it away.
All right. I'll have a PDF document that I can share out to everybody. I can drop that in the chat here in a little bit.
Yeah.
Actually, I wonder if I can drop that in the chat now. Um, I'll work on that after a bit. I'll probably get that out later so everybody can go back and look at that. I usually have it as a class handout. Um, this is a basic or intro to acid etching. There's a lot of different levels to acid etching. I break it down into three levels. This is the basic level. This is where we'll do etching with ferric chloride, which is technically a salt designed for printed circuit board etching. It's safe. You can use it indoors, flush it down the drain. It's also used by water treatment plants to help uh, treat water. So it's not, I wouldn't drink it, but you can put your hands in it. It's not going to hurt you. Just wash them off. It might stain them yellow. So, um, but we're going to talk about dealing with acids. And what we're going to do is talk a little bit about the history of it. And then we're going to talk about some of the projects and the materials. And we'll go through the process of this too. So, um, acid etching has been around for millennia, honestly. It was first discovered, or at least first recognized in discovery, for the intaglio methods by Albrecht Dürer and several others doing that in the late Renaissance period, or early Renaissance period, I should say. And then people started to realize arms and armor throughout the history was etched by various different means. And as people start digging back farther and farther, they find out, as I have, that we've seen evidence of acid etching for decorative use as far back as 5th century BC in many different cultures, actually. I've got evidence of it in Africa, I've got evidence of it in Europe, and I've got evidence of it in Asia. And I can share some of those references and resources with people as well. Um, so there's even acid etching was developed by itself in North America in the 9th century with Native Americans, and there's evidence of that as well. It's a lot of people have called it and downplayed it as a easy art to get into but part of the trouble is it's a very forgiving process. It allows you to make a lot of corrections along the way before you finally cut your part in your piece. But back in medieval or prehistoric times, you would have struggled getting the resources and materials to use for acid etching, which made it a much more noble and harder to do process, even as forgiving as it is. Acids weren't easy to come by or generate up until several centuries ago. Um, so there was a lot of value in what they did for acid etching as a decorative process. So I will walk through some of the parts of the process and show you why it's forgivable, more forgivable. You know, a lot of people confuse it with engraving. So I've got an engraver here. Um, Basically, an engraver is a sharp piece of metal that you use to cut designs into another piece of metal or wood or stone or whatever you want to cut it into. That takes a simple amount of tools, piece of steel or something harder than the material you're cutting into, and force, whether it be with a hammer, chunk of wood, your hand, etc. So engraving doesn't take a lot of tools, but takes a lot of practice to master because once you cut it, it's there forever. Acid etching is almost counter to that in the fact that you can paint on and scratch away and reapply, paint or resist, and you can do that many times until you have a finished product that you want to put into the acid that you feel is good enough quality. Let the acid do its job, pull the work back out, clean it up, and there you have a finished piece. So you can guarantee your artwork comes out the way you want. a little more easily that way. So that's what the forgiving part of the process is. Um, you can etch into most any materials. The evidence in the period was carnelian beads were etched in prehistoric times. There is brass and bronze were etched in those times as well as steel. So, who all knows the term imitation is the sincerest form of flattery, right? You also know that there was a lot of makers out there who wanted their stuff to look like somebody else's that was of high quality. And there were ways that people used that in period to etch decorations into items that made it look like it was something else. One of those most notable is plied steel construction, or later forms of the very earliest forms prior to Damascus. Celtic latin, 5th century, evidence of swords were found buried in the latin find that showed where they etched lines down the groove, down the center of the blades to imitate plied construction, knowing that plied construction was a superior form of construction at the time. So, and that was the earlier forms of Damascus. They noted that there were people out there trying to mimic to the people they're selling to. So they were using acid etching as a decorative technique. A lot of Norse people back then used it to bring out the pattern welded textures in Damascus patterns as well. So um, we're going to use it and apply it as an art for making medallions and or other parts of things that we do in the SCA, anachronistic pieces, and some of them period pieces that we go through and try to make sure that they look medieval to us. Um, so I've got a display here of different objects, different types of things that have been etched, and we'll go through the differences between engraving and etching. Engraving creates a V-shape cut, whereas acid etching creates a C-shaped cut in the material. And I didn't have any paper, but I got some. You can draw that so people can see. It's almost like symbols. When you go to engrave something, typically this is an engraved cut. This is an etched cut. What happens as centuries pass, these break off or wear due to age. This pits and gouges over age. And then when you get done, you have two things that look very similar, which makes it really hard for antiquities people to figure out whether it was engraved or whether it was etched. That's one of the struggles. Plus, a lot of the people that are writing the books don't seem to care which one is which. They just say it was etched or engraved, whichever they decide to call it. So researching it can be a little bit of a challenge. We'll just say that. Um, I've got several materials here that I've worked on. We've got brass. These are aluminum, and the dies are steel. I've done lots of steel items. This is steel as well. Um, I haven't done any etching on any non-metallic parts yet. I haven't done etched glass or any of those other like stone or anything like that. But this is one that was a failure of mine. And as you can see, the etch didn't come out clean. I had a lot of resistance flake up because I had this in a bowl and I was trying to etch 360. And the aggressive nature of the acid, it exchanges, it outgasses. So it heats up, the acid expands, turns into a bubble, release the gases. All those bubbles started to pull up the resist with it, and then you get inconsistent etches like this right here. So I had to cut this off and do something different. I ended up engraving this piece. Otherwise, it would have been several different etch processes just to get the full 360-degree etch on it. And I didn't want to have to try to etch this. As it was probably about 7 hours just to scratch this design into this just for acid etching that totally destroyed. But those are the life lessons we live with. Um, these were both aluminum etches really well with ferric chloride. Let me pull it here so you can see better. Um, this one looks like it's very pitted and looks sand cast, and this one does not. So part of this is how long you leave it in the ferric chloride. This is if I leave it in there as long as I want, which is probably only going to be about 15 to 20 minutes. This is if I leave it in there for about 5 to 10 minutes. It'll go down, but once it gets underneath that resist, it will start spreading, and that's what happens. It creates a neat little effect. Does both sides because it gets underneath everything. That's my wife's swan medallion I made for her long ago, and then a torch medallion. Um, but yeah, so be careful with ferric chloride and aluminum. It is very aggressive. Ferric chloride on coppers and brasses, not so bad. So this one here, some people here might recognize this. This is a plaque that I etched for Vashti's laurel belt. And you can see it's got a copper tone to it. When I suspended this piece upside down for the etch, it essentially copper plated itself back on there. The reason I didn't use this piece is if you can see right down here, it didn't etch very well through. I'm trying to get to where the light can show it, but there we go. See how it didn't get very deep on it like it did the top part? So, but steel wool cleans those things up too. That's how you go and clean up and give it a little bit of a polish. So you can see that polish that a lot more up, but you can still see over here hardly any etch was achieved compared to the other part. So that was just a piece that I set to the side, said, well, thankfully I etched extra pieces for her thing. Knowing that sometimes accidents happen. These are coin dies that I etched. One of the challenges with doing that is going to be trying to figure the item in reverse. So when you go to strike it, it shows up correctly on a coin. I have coins here that I've struck on these. And this is copper. As I shine it up a little bit here, you can see the image on there a little bit more readily. Acid etching is an okay medium for doing coins, but I wouldn't suggest it all the time. I've done it on several, and the challenge that I've found on it is because if you go back to that V-shaped cut versus the C-shaped cut, the C-shaped cut has those sharp corners which don't do well with striking into the surface. But they never lost. There were other. So that it'll strike, but it won't strike well, and it takes a lot more force than if you have a V-shaped cut. Forgot I had that one on there. So they turn out, but they're not ideal. So we'll put those out of the way. Does anybody have any questions? I like to keep an open dialogue on things just so people know, this is for their information. So I want to make sure if I miss something on this. All right. So the basics of etching is you're going to put down a resist. Oh, I'm sorry. I've got a question here. Oh, there we go. I turn up the chat so I can see it.
Does
All right.
the type of steel matter when using ferric chloride?
Yes. And I say yes. There's two types of steel that you want to worry about or the way you want to split it. It's either stainless steel or non-stainless. Stainless steel is resistant to acids. That's why it's stainless. So you don't want to use stainless steel if you're going to do ferric chloride. Regular steel will etch with ferric chloride. Um, so hopefully that helps you. The If you want to etch stainless steel, and I've done that, you'll use a process called electro etching, and I'm not going to go into that today. That's a wholly different process. But yeah, that's where you're going to use electricity to help you etch. But thank you. Want to make sure I answer the questions as we go too. So in period, the resist would have been um, typically one of two things. Would have been a bitumen mixed with mineral spirits, which essentially gets you asphaltum. Um, this is my really old can. I've got a new can of it too. It lasts for forever because I just add a little mineral spirits to thin it back out. Um, because the air will start to harden it up. But it's essentially like a tar that you thin out with mineral spirits. That is something that they use much later in period. Early periods used wax, beeswax. You melt it, you paint it on, and it acts like a resist. A lot of times they would mix something dark with it, probably lamp black or charcoal in a fine powder to darken it because if you just paint wax onto a surface, wax by itself is pretty clear and you can't see where you're scratching your resist away. So you want to see something like this or this where I've covered it in resist, right? That way you can see. And there's some lines that have happened over I didn't do the great job on this, but you can cover resist in many ways. What I'm talking about in this class is going to be uh, a Sharpie paint pen. But one of the things you're going to want to make sure is that it says oil based, right? Does anybody here know why I say it has to be oil based?
Because they also make water-based ones.
They do make water based paint pens. Sean's got it right. Water will wash it away. The acid will wash. The acid you're going to use is primarily water. There's anywhere from 60 to 90% water in the acid solutions. So I've used acrylic paint pens and learned that lesson the hard way. I also learned that lesson the hard way doing a more advanced technique where I build a clay dam around a large piece so I can etch it with just enough acid around the dammed part. That's an advanced technique. Only I thought I was going to be clever and use regular pottery clay. That did not work well. Um, so I brought this out because one of the things I did for this was I used a stencil method. So on this, what I would do is I'd take a piece of paper with my design on it, and I would tape it down to my metal, and I would trace it with a knife, and I'd peel up the shiny bits like this and set them to the side, and I'd paint my resist on. Once my resist of asphaltum dried, which takes usually 4 to 8 hours, then I would peel up the parts where the stencil was, leaving them shiny, right? And then that's what I wanted the acid to etch was that part of exposed metal. So these were the parts where I painted the asphaltum on. I pulled those up. Why are there bumps here? Because I wanted a background design, which was period to that culture, and I went with a paint pen and just put random dots all over the place, just so it gave that kind of texture to it. So you can paint on your design, you can scratch on your design, you can use stencils to aid you. All of those are acceptable. In period, they would have likely painted on their design, or they would have or they would use a stylus or a scribe. Painting on your design, I can come in here and I can draw on a shape, whatever shape that I might want to do, and whatever shape I draw on here, you're going to etch the part that's exposed. The stuff that's going to be underneath the paint will not etch. That's why it's called a resist. It's going to resist the etching. On this piece here that I coated, I'm going to try to go back in and kind of cover up some of the areas that I didn't get. And I'm okay with getting a little bit of paint on my fingers. I know it washes off. We'll show you how to scribe a design in there. And when I teach this class out in an SCA setting, I typically just have an open session where we gab. And what I have people do is pick their designs. And then I say, let's talk about the history of etching while we work on stuff, because it's like a sewing circle. We can sit there and we can talk about things while we do the fine motor details that help us work out a good etch. I should probably do. Put that up here on my thing so I'm not getting my table covered in paint, which is not a big deal anyways. My table's been around for 40 years. It'll survive a little paint. All right. Who has questions about the resist part?
We have a question. What about using vinyl?
So that's a great question. I've used vinyl as a stencil material for like a masking for like when I go to cut these out. So I put vinyl down there and I peel up the parts and then I paint on my resist and then I peel up the vinyl where I want it to expose. So I've used vinyl for a stencil that way. And I've also used vinyl as a stencil for electro etching. What I have not yet done is used vinyl as a direct stencil as my resist. I feel that it would work. Good point about the Sharpie on the copper. That's essentially what we're doing here. On aluminum, I don't know that the Sharpie will hold well enough. As you can see, it's very aggressive on the aluminum, and that was using a much harder resist, which is asphaltum. So I would suggest if you're going to try to do aluminum with ferric chloride, try to use some asphaltum or do a enamel kind of paint like a nail polish. Um, just don't use water-based paints.
Question, what do you use to clean up the resist?
That's a great question. I use good old mineral spirits. And that's why I have a second camera. If you can see the uh, mineral spirits, can you see? There we go. And you can get that at most hardware stores. So we'll go through that process. Ferric chloride. I just got a brand new bottle of it from the internet because I ran out over the years of doing this. My gallon jug of it has lasted about 15 years through different etches and such, and I needed to get some more.
Do you have to do anything in particular to have that shipped?
No, not for ferric chloride. Ferric chloride ships pretty easily because it's a hazardous chemical, but it's not, and it comes in a package. It's sealed in a package, sealed in another package. So they do protect it, but like I said, it's not an aggressive chemical like some of the others. Um, let's see here. I wanted to go to my projects folder and I want to drop this file into our discussion so that you guys have a reference material. Let's see here. Come over into Zoom. And I should be able to drop that in the chat, right? Admin restrictions. All right. Well, I tried. It's a PDF. Maybe an admin can help me with that later.
Yeah, you can, I'm gonna drop my email in here so you can email me and then I can drop it in.
Okay, great. But yeah, you can just send that to me in Facebook or something. If you don't want everybody to know your email.
That's fine. It's the one I use for the SCA.
Okay, great.
Send me cat pictures.
We got plenty of those. We got 3 cats. All right. Just doing little touch ups, mostly because any exposed piece of your part will get etch on it. Now you can go and clean those up with different tools like files or sandpaper, grinders, etc. It's just a matter of what you want to deal with. Um, but the paint pens work pretty good as long as you got everything covered. Is there any other questions before we start scribing in a design? All right. And I will add that to there. All right, that should be on its way. Where'd my video go? There we go. All right, so this should be dry enough. So there's 2 methods of putting your artwork in here as a scratching method. And if you look at this neat little piece of paper here, that's one method. So what you can do is I can take a design on a piece of paper like this. Now that's obviously too big, but you'll see the point. I can take my piece of paper and I can push down with a ballpoint pen. And if you want your design to stay in the right place, you better tape it down or not move your finger enough to make a difference. And you can see what it did right there. It pulled up some of the resist. And in some of the other areas, you can see faint little ghost images of where it is. So, scratching your design. Here's where it gets super technical. Just like, or not even just like engraving, even simpler than engraving, I can use pretty much any old thing I want to use to scratch a design in. I could even probably use something softer than the metal. It just has to be harder than the resist to scratch it away. While I could use wood to scratch it away, I've used all of these. I just take a needle, tape it to a dowel rod. Got a couple of those. Those are what I use for teaching class. Dental tools. X-Acto knife works great for many different things, and you can always change out blades when one gets dull from this. Pottery tools. Sharpen metal points. Wood carving tools. And as you can see all the tape on here, these are my high school drafting dividers. So, and that's what I've used for forever as my tool of choice. So I come in here and everybody sees what we've got for a design on here, how it's incomplete. So I'm going to come in here and I'm going to use my drafting dividers to scratch away the resist and expose the metal where I want it to eat. Now you see how much better that looks? Now you can see that there's some inconsistencies in what I did because I wasn't paying too close of attention. However, I'm old. I'm wearing glasses now. I've also found something else that helps me a lot. Magnification. That also allows you to get down into the details to make things look a lot more crisp and clean if that's your thing. Some people want to make it look like it was handmade, and that is fine with me. I do that on occasion too because I want it to look imperfect. But when I want to get some details and I want to add something, say like happy little stars, we can come in here and just kind of scribe in some happy little stars. Freehand those in, nice and easy with a scribe, like that. It's a fine motor and detail kind of thing that you want to do, and then you can add as much or as little detail as you want. The only thing that can limit you is the quality of your resist. And if I got this real close, you might see here, we can get real close. You can see how that resist has flaked around several areas. It's not a crisp and clean resist. It's not the best resist in the world, but it is effective. The best stuff would be the asphaltum because it stays pliable over a long period of time and allows you to get very fine detail cuts. That is the first part of that. The second part is the quality of your tool. You can see on this one, I've got a pretty fine point. This was the end I started with years ago. It's as dull as I am. So I moved over to a finer point so I can get better control. All right, questions on that part? All right. We're gonna set that to the side there. um, the etching process. This is where use of PPE or personal protective equipment is highly suggested. Um, like I said, ferric chloride is not super dangerous to anybody, but it will stain. It will get on clothing and such. Nitrile gloves, always a good thing to have on hand, so that if I wanted to put my hand in there and mess with my piece, I could. All right. So I've got my design scratched in my piece, and I'm going to put it down inside this bowl. I don't need a lot of acid to do a lot of work on this. So I'm going to put it in the corner, and I'm going to use something to just kind of lift up the end of this, right? So that all the acid goes to one corner. That way I don't have to use any more acid than necessary for this. Now, ferric chloride etches slowly, so you don't need to sit and lord over it. Um, and I tend to brush bubbles away, which is um, a good thing when you're doing something like nitric, but ferric chloride doesn't out bubble. So what I do is I brush it every 15 minutes when I've got it artwork, when the artwork is face up, and that is to keep it from collecting the copper that's leached out of it so it doesn't deposit it back into it. All right, I'm going to do this over here safely. And set it back up there. Ferric chloride is brown in color. That's the normal color for it. It's kind of in the name too. It's ferric chloride. Iron ferric is Latin for iron. So it's an iron chloride. So I usually let a piece sit in the or in the acid for this. I let it sit in there for an hour and a half minimum. Obviously, we don't want to sit here and watch grass grow or acid etch in this case.
Wayne, what concentration there is the
The
acid?
concentration of the ferric chloride,
Yeah.
42%.
And we have another question. Can you reuse the acid?
You can. Like, so in this case, I dumped in there way more acid than what will be needed to etch the little bitty part of the design that I have on this piece. So typically when I do this like in a class, I'll throw as many pieces as I can to fill the bottom. I'll cover them all at once so they all etch together because you might as well. There's plenty of acid there. I probably only need probably about a third to a quarter of the amount of acid in there to do a decent etch. So yeah, I could dump it back in with my bottle. I'm not going to because if I reuse it too much, it'll super dilute the whole bottle down. So I'll just take this little bit and I'll just wash it down the sink so that the next time I go to use my ferric chloride, I know I've got it at full concentration. Now, if I want to save this as a use into a smaller container and know this is my reuse container, the problem I have with that is the more you use it, the less control you have. And I want to have control over my finished product as much as possible. So I tend to not reuse it. That gallon jug, ferric chloride cost me, I think, $35 on the internet. And that will etch 1,000 pieces of brass. And when I say 1,000 pieces, 1,000 pieces the size of a, I don't know, medallion, inch and a half diameter. What I'm using here is a little coin blank that I bought off Bopper Metal Supply, and that's in the document I sent. They sell all these little brass, copper, nickel, silver type blanks you can get for all sorts of things. You can even get them with holes because they sell like dog tags and stuff. They sell them for all sorts of different shops. So I should buy a bunch of brass blanks with a hole in there so we can just make medallions and have the hole already in it. So I hadn't thought about that till just now, but these are just coin blanks that I had sitting around.
Do you have any concerns about fuming? I know a lot of places do their acid etching under a hood.
Yeah, so I'm gonna build an acid hood inside down here in my workshop, but I don't need it for ferric chloride. Ferric chloride doesn't outgas anything dangerous at all, um, and its reaction isn't volatile enough for that. Now, I do use nitric and hydrochloric acids and going to be working with some sulfurics. All of those things, yes, 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 yes. Do outside. I've always ever done them outside, never inside. And I've had a fan on it, blowing across it, not direct on it, but just blowing the wind across and away from me because dangerous fumes come from that. I want to build a fume hood for inside the house so I can etch during the winter. One of the things that a lot of people don't talk about with acid etching is temperature is a big component to acid etching. I am in my basement, so I am temperature controlled. I'm about 70 degrees, and it's not going to change throughout the year down here. So I can control it. I can also control the humidity. Humidity plays a smaller impact to it than just temperature. Um, Acid etching is an exothermic process, so it will generate heat as it does it. With ferric chloride, you won't generate much heat because it's not an aggressive etch. When I use the ferric chloride on aluminum, I will generate lots of heat. You'll definitely want to do that outside for the fumes on it as well. And then nitric acid for sure, do outside, and it produces a lot of heat as well. So when I pulled this crossguard piece that I 360 etched out of the water, it was hot to the touch or out of the acid. And I pulled it out using nitrile gloves, trust me. And I actually used stainless steel tongs to pick it up, but then I had to kind of manipulate it with my hands. I still had rubber gloves on. Um, I wear safety glasses as well when I go to etch with nitric and stuff because I don't want that stuff spraying up into my eyes. Or I don't, I can live with a pock mark in my face or a damaged T-shirt, but not being able to see out of my eyes, I think I would have some issues with that. So safety first. I may joke at times and say safety third when I'm out on the battlefield fighting or something, but for this, no, safety first. All right. Whenever you're wanting to brush bubbles away, I have a bag of what's called flux brushes. You can go to Harbor Freight or hardware stores and you can get flux brushes. Flux brushes are made for when you want to do soldering and use flux for soldering pipes. And you can do it and they use flux for welding and they use flux for all sorts of different things. And the reason why you use flux brushes, that pack of like 40 brushes cost me like $5 at Harbor Freight. But the brush itself is made out of horsehair. It's a natural fiber that resists the acids. If you were to use a normal painter's brush, those are typically synthetic fabrics like nylon. So if I wanted to brush and I had a brush like this, right? Those bristles are made out of synthetic fibers that the acids can't consume. A lot of times they'll react violently with them and they'll just burn your brush away and then leave junk in your acid. You don't want that. So I always use horsehair brushes since they're so cheap and they're basically disposable after a while. And all I'm doing is I'm just brushing the top of this very gently. And you can't see it with the lighting in here. I wish you could. You'll see like a little bit of wispy blackness moving around in it. And that's just, I'm brushing off the stuff that has been um, eaten out of the exposed area. I'll work on this in the future to where I can try to probably get a good camera angle and light in there. I'll probably buy a webcam or two just for showing some of these processes in a little better detail. Um, so we can see about trying to get that in there. It's kind of hard to see. I'm not gonna try to force it down there too much on you, but and then I just Tap the acid in there. I set it on something like a paper towel so that it doesn't destroy anything around it. And that is the etching process for copper and brass. Um, and you'll do that for about 90 minutes. Now, I told you I'm not going to keep you for 90 minutes. So we're just going to let that sit there. Actually, I'm going to move it so it's out of the way. Put it up on a CNC router and get it out of the way here. All right. So we have something that somebody left with me that they etched at an event long ago. Their design is still here. It's been etched, but the resist has not been removed. So once you've pulled your piece out from your etch, you'll want to rinse it off with water and with PCB etchant or ferric chloride, you can just dump down your drain and rinse it out. It's safe for that. I always put it on a piece of paper towel because now we're going to get a little messy with it. This is where you use mineral spirits to clean it up. And I just tip a little bit of it onto a cloth. And just rub it across there. And you can see it went from black to shiny. So you can see the back part of this, still very black. And then I flip this inside out, and there's still plenty of mineral spirits on it, and just keep rubbing it. Then you can work on the outside edges. One thing you're going to want to notice when you go to coat a piece that you're going to immerse in acid like that, don't forget there's three sides to this thing: top, bottom, and the thin edge is the truth. That's an old paradigm. There's three sides to every story. There's yours, there's mine, and then there's the thin edge is the truth. And you want to make sure that you take care of that. All right. Put my cap back on that. All right. So now you're left with this piece here. And it's got a bit of a coppery color to it because it's leached that copper out onto there and it's kind of plated it. Can be a nice effect. It's hard to maintain sometimes. If I go real lightly with a piece of steel wool over it, I can polish up my brass and polish up that copper plating so it stays on there a little bit.
We have a question. Does ferric sulfate etch deep enough to enamel for cloisonne?
Um, I don't know about ferric sulfate. I have not used that. Or are you asking about the acid I'm using right now? Okay, the acid right now I'm using is ferric chloride. I just wanted to make sure we're talking apples to apples. Uh, yes, it will etch deep enough for cloisonne enameling. Um, so here's the thing with um, acid etching. Acid etching is depth over time. So you can see where that polished up a lot nicer. You can see it's got all the resist off. It's got a little bit of shine to it. So, um, is it cloisonne? I thought it was champlive that was the enamel method that uses that. Maybe I'm mixing them up. It's
Both
not important.
cloisonne and champlevé both use acid techniques depending on what you're doing with it.
Okay. Yeah, I couldn't remember. Yes, it will etch deep enough. You can etch all the way through this 16th of an inch coin if you wanted to. It's a matter of how long do you leave it in the acid and do you have enough acid there to continue to react in that method. So I've gotten, let's go back to that Vashti piece. Where did I put it? There it is, underneath there. All right. So this depth right here, this is about, I'll say this is probably 20 gauge material. So it's probably 40 thou thick, maybe 18 gauge material. And this depth is almost halfway through it. So it's probably about 20 thou thick depth on this cut here. Um, so yeah, you could fill that with your glass. I'm not sure. I don't know how thin you can get glass for that to do that and show all the dots through and stuff like that. But I can certainly have left this in there longer for a deeper etch. So there, another method for doing this, like I showed you, this was face up. I told you I etched this one face down. So I taped to the back of this piece and I lowered this down into the acid and let it etch, suspending this piece with the face down in the acid. And I didn't brush it at all during that time because the weight of the material would fall away from it. Whereas if I left it face up, I'd have to brush material off so it continued to etch down in there. Otherwise, the material would deposit back on there and stop it from etching as well. So it's a time thing. I haven't tried etching it, leaving it in there to see how deep of an etch I can get. I've got a plan to do that. So like I said, Bopper Supply, I bought a whole bunch of brass squares. I've got copper and nickel squares as well as some steel squares. And I'm going to do all sorts of samples. I'm going to try different acids and how well do they etch. We're going to try the hydrochlorics, the ferric chlorides, the nitrics, the sulfurics, and then also acetic acid. Acetic acid is a pretty common acid. Who here knows what acetic acid is in the modern world?
Vinegar.
That's right, vinegar. 5% by volume. They've now started selling 20 and 30% by volume vinegar at the hardware stores with big danger symbols. So I'm going to start trying to see how well a vinegar can do too.
There are
That
two
was
questions in the chat for you.
okay.
If you don't know if it's brass or bronze, is the process the same?
Yes, the process is the same, brass and bronze. The primary element that you're etching is copper. And so copper, brass, and bronze all etch pretty much the same.
And the second question is, do you have a preference for suspended versus brushed?
Uh, no, not really. It's just more experience with the brushed method. I think I kind of like the idea of suspended, so I can just suspend it and leave it. Make sure I set a timer. Otherwise, you might come back to a piece that's disappeared. And there's several different ways of doing the suspended. I use tape. Some people glue it to a piece of foam um, and let it just float, or piece of wood or whatever. There's lots of ways of doing that. Um, but I just do the face up method. That way, when students go to the class and you're brushing things away every 15 minutes, gives us one, that gives us something to do while we chat. And two is you can kind of see that the artwork's still there, and you can see as can't see it etching deep because you've got the dark acid that you're, or the ferric chloride's dark, and it's kind of hard to see through. But you can still see the wisps of things coming off of it, and you know that it's still working. So that's just more of a visual effect than anything. But they're both very effective. I've etched brass with nitric as well, and it turns the water blue as it leaches the copper out. Real pretty, and how it etches too. But there again, do that outside with nitric. So that is pretty much the basic process for acid etching. Please, does anyone else have other questions? All right. No questions?
Does your handout give places to purchase supplies?
Yes, the handout does. Some of the, when I first wrote it, I lived in Wichita, Kansas. So there's some places on there like the yard store, which you'll only get in Wichita. But I did add Bopper Metal Supply where I bought a lot of these little discs and squares and stuff. Amazon carries a lot of things. I've even broke it down into whether it's resist, whether it is your acids, whether it's your base materials, so that you got a selection of different places you can go to buy supplies.
Speaking of your document, I did put in a Google link. If that does not work for everyone, the handout will also be attached later this evening to the Rush calendar on the Calendar website as a PDF. So you'll be able to get the handout. Two
And
more questions.
I
Go
want to
ahead.
make sure if people have questions, please reach out to me via email. I love sharing what I do with people.
So two more questions. Can you etch on silver plate?
Yes, etch silver can etch. I have not done it, so I can't talk you through the procedure of it and what to use, but I do know that it has been done.
And was that just a regular Tupperware container you used?
Yes, it was. So I guess I didn't talk about that part of things, and that's a good eye. It's Rubbermaid slash Tupperware. I don't care what you call it. It's the same thing. I also, when I'm doing things, I use a Pyrex dish. I use this glass as one of the best acid resistance around. We store most of our acids in glass bottles. I've got my nitric and my hydrochloric and stuff like that that's dangerous stored in a glass bottle with reagent quality stoppers. But I bought this Pyrex dish years ago, and this has been my etching dish because how dare I touch my wife's cooking ware? So I bought
Good
this one
boy.
for me. But I keep that with all my acid stuff. I didn't think I needed the big dish, so I used something smaller, piece of Tupperware. I've used uh, who here is eating the mac and cheese that you cook in a microwave for 3 minutes, right? I just rinsed out a tub, made sure it was clean, and I used that to etch a medallion, a peerage medallion, no less. So it's just something plastic that will resist the acid. Any other questions?
We are right at time. Before everyone leaves, do you mind go ahead and type your email into the chat
Oh,
just for
yes, of
anybody who
course.
has questions? And I'm going to go ahead and stop the recording.